Good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. In this video, we are continuing and we are looking at the calculus 2. Alright, now in this video, we are looking at the example question for tangents and normals. This is example 3. It reads, find A, the coordinates of the point on the curve y is equal to 3x squared plus 2x plus 1, where the tangent is parallel to the line 4x plus y is equal to 5, and B, the equation of the normal at that point. Okay, so what we need to do first of all is to write the curve that we have been given. Okay, so I've been given this particular function, which is y is equal to 3x squared plus 2x plus 1. And then they are saying that where the tangent is parallel to the line, okay, so the line here, right here, 4x plus y is equal to 5. What we need to do is, we need to write this in the slope-intercept form or the gradient-intercept form, okay, because the gradient of this line will be the same as the gradient of the tangent at that point that they are asking for, the coordinates of the point, alright, so that I mean. So it means that we should find the gradient of this, okay? So we have 4x plus y is equal to 5. It will be y is equal to negative 4x plus 5. So the slope-intercept form or the gradient-intercept form is y is equal to mx plus c. So we have to write our equation in this form, okay? So this is 5. So y is equal to mx plus c, alright? Where m is the gradient. So the gradient in this case would be negative 4. And then we would say what? M is equal to negative 4. So that's the gradient that we are going to use. So it means that when we find our dy dx is going to be equal to negative 4. That's what that statement means. To continue, we are going to clean up. Okay? Well, we know that also m is equal to negative 4. Let me write it here. M is equal to negative 4. To continue, dy dx is going to be equal to 6x plus 2, like that. And then we are going to say when dy dx is equal to negative 4. So it's going to be 6x plus 2 is equal to negative 4. And then it's going to be 6x is equal to negative 4 minus 2. 6x is going to be equal to negative 6. You divide by 6, divide by 6. 6 can go into itself 1, into 6 it's a 1, into itself 1, into 6 it's a 1. X is equal to a negative 1. So what we have found actually is, because we were saying that when dy dx is equal to a negative 4, so it means that we already know the gradient. M or dy dx is a function that's used to find m. Okay? A function that is used to find m. And what is m? M is the gradient. So it's a function used to find the gradient. So, because we already know that our gradient is negative 4, it means that whatever we have here should equal to negative 4, and therefore we found our x to be equal to a negative 1. So we are going to say, since we have found our x coordinate for question A, it wanted us to find the coordinates of the point on the curve. Alright? We're going to say when x is equal to negative 1, y is equal to 3 multiplied by negative 1 squared plus a 2 multiplied by negative 1 plus a 1. It's going to be 3 multiplied by a positive 1 minus 2 plus 1. Like that. And then to continue, it's going to be 3 minus 2 plus 1. 3 minus 2 is a 1, 1 plus 1 is a 2, so y is equal to a 2. Therefore, the coordinate will be what? The coordinate will be negative 1, comma positive 2. So what are we going to say? We are going to write our answers down here. So for question A, the point is negative 1, comma positive 2. That's what we have found. And then question B, they are saying the equation of the normal at that point. Okay? So for question B, what we know is the gradient, which we can call m1, so m1, okay, is equal to the gradient that we found in the initial step was negative 4. Okay, the gradient is coming from this equation here, so the gradient was a negative 4. m1 is equal to a negative 4. And then we use the product of perpendicular lines, which is m1 times m2 is equal to negative 1, like that. Then negative 4 times m2 is equal to negative 1. We divide both sides by negative 4 by negative 4. Negative 4 can go into itself 1, into negative 4, again 1. And then you're going to have m2 is equal to a 1 over 4. So that's your second gradient. That's the gradient that we are going to use for the normal. Okay? So for the tangent, it will just be the m that we found. But for the normal, we need to find our m2. Okay, so we can say m is equal to positive 1 over 4, and then the coordinate is negative 1, positive 2. This will be our x1. Hope you can see that x1, y1, like that. So y minus y1, let me write that properly, y minus y1 is equal to mx minus x1. So it's going to be y minus 2 is equal to 1 over 4, x minus x1 is negative 1 in brackets. So y minus 2 is equal to 1 over 4 x plus a 1 in brackets. And then we clean up. So we can just remove everything. So it means we are going to say y minus 2 is equal to 1 over 4x plus 1 over 4, like that. Then to continue, the lowest common denominator that you can see there is what? It is a positive 4. So we multiply throughout by the positive 4. We're going to have a 4y minus 8 is equal to x plus 1, like that. And then we write it in the standard form. I'm going to write it in the form ax plus by plus c is equal to 0. This is the standard form for equations. Okay? So I'm going to say x minus 4y plus 1 plus 8 is equal to 0. I hope you have understood that. So the 8 will go that side, the 4y will go that side, the 8 becomes positive, the 4y becomes negative. So it's going to be x minus 4y plus 9 is equal to 0. So the equation to the normal, therefore, will be x minus 4y plus 9 is equal to 0. This marks the end of this video. Thank you so much for watching. I hope you can see the solutions there. This has been Cornelius Tubinda with another video, and bye bye.